Okay, so today, what we're going to be talking about for 5.1 day 2 is we're going to talk about two things. The natural base e and how that pertains to exponential functions, and then compound interest. So those two things that we're going to work on. So we'll start our little lesson here talking about recalling what we learned yesterday from exponential functions. If I give you exponential f of x equals a to the x, what do we call this a part down here? What do we call that? That's called the base. Very good. Okay. And what do we call the x up here? Yep, you got it. That's the exponent, all right? So now, if we're talking about the natural base, okay, we're going to let our base be this e thing. So we're going to have f of x is equal to e to the x, where e is this natural number that's about 2.71828, and so on and so forth. It's an irrational number, okay? Yeah, it's just like pi, right? So when you think of pi, you think of 3.14. When you think of e, you're going to think of 2.71. So when we have this equation here, this is the natural base e. The natural base e. So all we did was we took our regular base of a, being any real number, and we let that base become the natural base e. So all we did was we changed from a to e. So now we have this new exponential function, which we call the natural base exponential function. All right? So let's get an idea of what this looks like. So for number 2, let's take a look at the graph for the function f of x equals e to the x. Now remember, e is about 2.71, so e is really close to the whole number 3, right? So when we graph this on a coordinate plane, remember, we still have our 2 anchor points for our exponential functions. Okay, 1, 2, 3, 4. I'm going to go up to 5, and then go 1, 2, 3, 4 over here. Down 1, 2, left 1. Okay. So what is the anchor point? What's one guaranteed anchor point for any standard exponential function? What is it going to be? 1 comma what? Yeah, you're on it. So 1 comma e. So that's going to be one of them, right? So this is going to be the point 1 comma e. And notice how I write e, and notice where it is. It's almost up to 3, because this is the point 3, right? And e is about 2.71. So it's almost up to the point 3. So it's really, really close to it. What's the other anchor point? The other easy anchor point? If 0 comma 1. Very good. So I'm going to have this. Here's my graph for e to the x. Notice it looks just like every other exponential function, right? We still have our asymptote right here, which is the line y equals 0, and all that's still good to go. So what would the domain for my f of x equals e to the x? What would the domain be? All x values. What could I put? Yeah, you got it, Bobby. Nice job. All real numbers x. What about my range? Greater than 0. Yeah, you got it. So I have my domain, and I've got my range for this. Okay, so one thing we're going to do with exponential functions is learn how to evaluate them. And we can evaluate them with a base of e. So let me show you where that is on the calculator. So if I want to evaluate f of x equals e to the negative 2, you have two options. You can put e, so the e button is in two places. It's the division sign, right above the division sign, or it's the above this ln button, which we're going to talk about. So check it out. If I just put second the division sign, notice I get my regular standard e, which is about 2.71828, blah, 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 right? So if I want to raise that to a power of negative 2, I would go second e to the negative 2. Push enter, and we're going to round to 2 decimal places. So what do I get when I round to 2 decimal places for this one? 0.14, right? Now the other option is you can push second ln, and notice it automatically puts the caret there for you. Very cool. So then I can go negative 2 and get my answer with less keystrokes. So it'll be 0.14 no matter how you do it, right? So we'll write in here, we'll say this is about 0.14 when we round to 2 decimal places. So let's go ahead and evaluate the other two really quickly. I'll clear this out. So we'll go second e to the 0.25. Get an answer. I got 1.28, right? And then we'll go second e to the negative 0.3, which I get an answer of 0.74. Okay. So I'm looking at 1.28 and I'm looking at 0.74. All right, so how does this talk? How does exponential functions tie into interest? Well, who's ever heard of interest before in their life? Raise your hands. Let the record show 3 people have their hands raised. Wow. Okay, good. Yeah, all right. Interest. Well, there are. Yeah, in banking. Okay, good. There are 2 types of interest. All right. The 2 types of interest are, the first one is called simple interest. And yeah, there's 2 types of interest. There's simple interest and there's compounded interest. All right. So these are the 2 types. And so a simple interest means that you have a one-time interest charge. Interest charge. Okay? So one-time interest charge. A compound interest means that your interest rolls over on itself and it keeps going. That's the normal one. This is the one that most people use, but it stems from this idea of simple interest. Okay? So what I'm going to do is I'm going to take you through each of these 2 types of interest with a focus on compound because it ties back into the natural base E, which we started at the beginning of the lesson, okay? So same box here. Let's talk about simple interest. Okay, so let's say you give your buddy 35 bucks and you say, okay, I want 10% interest on my 35 bucks. So what is that person going to give you back? 38.50. Good. How did you do that so fast? How did you get 38.50 from that? What did you do? He says just take 10% of 35, which is $3.50, and then add it back onto your 35 to make 38.50. So how much profit did you make from loaning your buddy 35 bucks? $3.50, all right? That's you making money by lending money. That's a simple interest, right? So there is a formula for that, and the formula is A equals P times 1 plus R. So what you just did is this formula, Bobby, in your head, all right? So let me explain this to you. A stands for the amount. Forgot my end. The amount you're going to get at the end, okay? P stands for the principal, right? And not the principal like the principal of the school, like the principal means what you're starting with, how much you're starting with. So your initial amount. R is going to represent your rate as a decimal. Okay? Always make sure that your rate is represented as a decimal. So the example that I gave you was this one. I said, okay, let's say you have 35 bucks and your friend says, hey man, I need 35 bucks. You say, cool, I'll give you that 35 bucks, but I'm going to charge you 10% interest, a one-time deal. Okay? So now you get why there's the 1 there. Awesome, right? What was this 1 all about? Because you have to take 100% and then some, right? So I'm going to take A equals P times 1 plus R. Okay, so the amount I'm going to get is going to be the principal, 35 bucks. 1 plus the rate was 10%, right? We said 10%. So what's 10% represented as a decimal? 0.1, very good, okay? 0.1. So the amount I'm going to get is going to be 35 times 1.1 because 1 plus 0.1 is 1.1. When you run that in the calculator, or you realize you're getting 38.50. So that means you made a profit of $3.50 when you subtract the 2, okay? So the amount you get at the end is 38.50, and if I subtract that from my original amount, I made a profit of $3.50, right? This is the idea of simple interest. It's a one-time deal, happens at the end of whenever that time frame is, you pay it back, and it's a one-time deal. That's the idea behind simple interest. What do you think so far? Okay, so the second type of interest is called compound interest, and it can happen in 2 ways. Okay, so we're kind of breaking off here. It can happen in 2 ways. The first way, A, is it can happen in stages. And what I mean by that, it can happen 1 time a year. It can happen 2 times a year. It can happen 4 times a year, or it can happen every single day, or in some other variation. It can happen in stages, so compound interest, which is the majority of what happens, or it can happen continuously. And if it happens continuously, that's where we use E, this natural base E again, okay? So let's talk about each of these ways individually. So we're talking about compound interest can happen two ways. It can happen in stages or it can happen continuously. So let's talk about the first part here in stages here. So the formula that we're going to use for this one is going to be P1 plus R over N all raised to the NT. So let me tell you what each of these things mean. So this is an important piece right here. We're going to want to make sure that we pay close attention to this formula. All right, so let me tell you what all the pieces are. A is still the amount. P is still the principal. R is still your percentage rate as a decimal. Okay? N is equal to the number of times we're going to compound per year. Okay? So N is the number of times we're going to compound per year. This could happen if it was, for an example, if we see the word quarterly. Okay? That means that our N would be 4 because there are 4 quarters in a year, right? Okay? If it happened monthly, then our N would be 12 because it would be 12 times in a year. If it happened daily, our N would be what? How many days in a year? 365, right? There's 365 days in a year. So depending on, so N gives you the number of times we're going to compound per year. And that could vary. It could be quarterly, monthly, or daily. And then T, of course, is equal to time in years. Time in years. Okay, so this information is very handy and ties in and tells you what each of those pieces are right over there. So, okay, so here's an example. We have $12,000. We're going to put it in the bank. Bank is offering 9% interest rate, which is really sweet. I don't know if you ever find that, and it's huge, right? And we're going to do it for a period of 5 years, okay? So we're going to compare two different options. The bank teller says, okay, you have two different options. You can either compound this money quarterly. So in this case, the N would be what if I'm compounding quarterly, everybody? It would be 4 times per year. Or monthly, our N is going to be what if I compounded monthly? 12. Very good, okay? So before we even begin here, comparing the two, which option, compounded quarterly or compounded monthly, do you think is going to give you more money at the end of your 5 years? Okay, I heard monthly. You think it's the same? I heard same and I heard monthly.
When you divide, it's like by a lesser factor than an exponent.
So if we have one vote for monthly, we have one vote for monthly, we have one vote for the same, we have a couple of votes for not sure yet, right? Okay. All right, well, let's see how the algebra plays out for us, all right? We're gonna do this in blue. So the amount that we're gonna get is going to be the principal times 1 plus R over N all raised to the NT. Okay, I should keep these the same to the NT. Okay, and then this one, amount we get is going to be the principal times 1 plus R over N all to the NT. Okay, so let's plug in what we know. The amount we're going to get is going to be the principal, which is $12,000. That's going to stay the same for both of these. 1 plus the rate is going to be 0.09 divided by, what's the N in this case for compounded quarterly, everybody? 4, good. I'm going to raise that to the 4 times, how many years are we doing this? Times 5, good. Let's set up our other equation. Okay, this is going to be 12,000 times 1 plus 0.09 divided by, now in this case, our N is going to be a 12. So we're going to raise that to the 12 times 5. So do you see the difference in the setup? The only difference is what I'm highlighting here for you. You see the difference in the setup? We're only changing the times that we compound, either quarterly or monthly. All right? So what we'll do is we're going to do part A, or we're going to do compounded quarterly together, and then you're going to do monthly on your own to make sure you can do it in the calculator. So here's how we're going to do it. All right? So take your calculators out. Here's how I want you to do this. Okay, I want you to do the parentheses first. So we're going to do parentheses. We're going to go 1 plus parenthesis, 0.09 divided by 4, close parenthesis, close parenthesis. So do you see how I'm only doing the middle chunk of my equation? Then I'm going to do a caret for an exponent. Okay. Now you can either do, since it's just 4 times 5, we know that, which is just 20. Or if you needed to use another set of parentheses if it was a funky number. But for us, we know that 4 times 5 is 20, so we'll do 20. And we get this answer. Then we multiply that by what, everybody? By 1,200. Very, very good. And we get a grand total of $18,000, 726.11 cents. So I'm going to write that down, okay? Which is awesome, by the way. Good luck finding that in the real world. So, so this will give us $18,726.11, okay? So that's what I got for this one. I would like you guys to do the monthly, and we're going to compare it at the end. So, Lauren, what did you get for when you did compounded monthly? $788 and $17.88. Okay, so what is the difference between these two right here? What's the difference between those two? $62.06. So which option would you rather go for? You'd go for monthly, right? Why would you go for monthly? Because it is $62 more, right? Okay, good. I agree with you on that. Okay, so here's what I want you to do. New box here for yourselves, okay? This is, I think, it's box number 4, right? It's the 4th one? Or just the 3rd one? Oh, it's the 5th one. Jeez, sorry. Okay, so box number 5 here. It's a U try. Okay, what I want you to do is I'm going to give you $15,000. That'd be sweet if I gave you $15,000. I'm going to give you a rate at 3%, and I'm going to give you an 8-year time frame. And what I would like you to do, okay, and you guys can all work together on this, I want you to do it quarterly. Okay, I want you to do it monthly, and I want you to do it daily. Okay, so I want you to compound quarterly, monthly, and daily and get those 3 values out for here, and we should see some kind of a trend. So I want you to work together. You can split it up however you want, but let's do quarterly, monthly, and daily compounding, $15,000, 3% for 8 years, okay? So here we go. We've got quarterly, monthly, daily. We have these values that we did if we plugged them in. What can you say about the more times that we compound, right? Quarterly would be 4 times. Monthly would be 12 times. Daily would be 365 times. So what can you say? What does it seem like?
It grows, but the difference is like slightly less.
Okay, it grows, but the difference is slightly less. That's a pretty good statement. What else? Anybody see anything else that they see on that? Does that make sense, right? So my question then to you is, okay, if I did daily, what if I continued on and what if I did it every single second? Would I get more money?
Yeah, but like it would be even less than like it wouldn't
It would be
more,
less
it'd
than
be
$5.
more, but it'd be
Would it be more than daily?
yeah.
Yes.
Yeah, okay.
It'd
What
be
it,
like
But it wouldn't be that much.
but it wouldn't.
Difference wouldn't be the same as like quarterly.
But the difference would be
$1, $2.
smaller. Okay. What if I did it every half second?
It'd be like cents.
Would I get even more?
Yeah, but not very much.
Yeah, but not very much. Okay. What if I did it every third of a second? Would I get more money? A little bit more money. So my question is, how do I get the most money? How do I maximize it? Yeah, right. If I let this keep going down to say infinity, what if I never ever stop compounding? That's right. What if I use continuous compounding, right?
Isn't E like it can get cut in half like
Right.
infinite amount of times and never reach 0?
Yeah, we're on to something here, right? You guys are on to something, right? So this is our last idea here. This is the other type of compounding, and this is compounding continuously. So this is our 6th box, right? No, not too bad, okay? So this is continuous compounding. All right. So for continuous compounding, let's start. We had this one. We had A equals P 1 plus R over N all, dang it, I keep doing that. All to the NT, right? That's the original one we had. Well, do you guys know how we get the number E? We get the number e by letting 1 plus r over n to the n as n goes to infinity. That's an 8. Holy cow. Okay? So as this n goes to infinity, this approaches the number, e approaches the number 2.71. Well, doesn't that look a whole lot like this over here? Yeah, it does, right? There's definitely some similarities there. In a few steps of algebra, we'll see that this whole middle chunk, you get this formula for it. A equals P e to the RT. So this one is our continuously compounded interest formula. PE to the RT. A lot of students call it PERT. So when we are compounding continuously, we use PERT. A equals PE to the RT. So let's do that same example. Let's do $15,000, 3%, 8 years, and we're going to compound continuously. That's what CC means, compounded continuously. Okay, so we expect our answer to be more than $19,068.55. How much more do you expect it to be? Just a couple of cents, couple of dollars? What do you think?
I think a few dollars.
A few dollars more? Okay, but not very big. All right, let's see. All right, let's see here. So our amount is going to be the principal, which is $15,000, e to the r, which is 0.03 times 8. That's it. That's a really, really simple formula in terms of compounding continuously. So let's go ahead and see what we're going to get. We're going to compare this to 15,000, whatever it was before. Okay? So we're going to go second e, which is the natural log button. We're going to go 0.03 times 8 in my exponent. So I'm doing my exponent first. Push enter. Then I need to multiply by what, everybody? My 15, my original 15,000 that I started with. And I'm getting not even a dollar more, right?
No way.
Whoa, that was weird. Someone must have pushed enter there. So did you guys get, what did you guys get? We get 19,000. Help me out, I lost it.
19,068.74.
0.7, so 74 cents. And if we compare that to what we had up here before, 55 cents, how much more is that?
That's so dumb.
Right? Okay. So we get the most amount of money for compounding continuously, but it's not much more.